All right, so yesterday we focused on prisms and cylinders. Today we're going to focus on pyramids and cones and finding lateral and surface areas of those. Your entry task, and again, this is just kind of review, so I would encourage you to pause this and try it out yourself, is to find the surface area of this prism that's right here. We're going to assume that this is a right triangle right here. So our surface area is going to be the lateral area plus the area of the two bases. I would encourage you again, pause this, try it out yourself. This tends to be a problem that I've noticed on reviews and tests and quizzes that people get stuck. So I really want you to try it yourself so that you can kind of check and see where you are. So I'm going to go over the answer now. So again, pause if you haven't yet. The first thing I encouraged you to do in our PowerPoint yesterday was outline the bases, always, 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 so that you know what you're trying to look for, right? So we have a triangular base on the left and the right. Notice that the rectangles don't have any parallel and congruent sides to make it a prism. So it has to be the triangle. Where we get stuck on this triangle, though, is that we have 5 and 12, but we don't have the hypotenuse of this triangle. So if we assume that it's a right triangle, then we know that we can use the Pythagorean theorem to find the hypotenuse. So you can do 5 squared plus 12 squared equals the hypotenuse squared and figure out what hypotenuse is. I noticed though that this is actually a 5, 12, 13 triangle. Those pesky Pythagorean triples are never going to leave you alone this year. So now that I know that, I know that my lateral area, right, kind of the area of all of these rectangles here is going to be the perimeter times the height. So I'm going to do 5 plus 12 plus 13 and get a perimeter of 30 feet. And then the height of the prism is going to be 21 feet. Remember that the height has to connect from one base to the other. So it has to be this length of 21 feet. So the lateral area, perimeter times the height, is going to be 630 feet squared. So then the base, the area of my base will be 1/2 base times height because it's a triangle. So 1/2 12 times 5, and that gives me 30 feet squared for one of my bases. So then for my surface area, I'm going to do my lateral area of 630 feet squared plus 2 times one of my bases of 30, which will give me a total area of 690 feet squared. All right, we are into some official vocabulary for section 11.3. Our first definition is a pyramid. So a pyramid is a polyhedron whose one base, remember the pyramids only have one base, is a regular polygon, and then the lateral faces are going to be triangles. So we are going to only focus on regular polygons in this chapter. So here's an example, right? We have a pyramid that has one base that is a square, and then all of the lateral faces around the sides are triangles, okay? Here's another one where we have a hexagonal base down here. So it's called a hexagonal pyramid. And then each of those lateral faces are triangles. Now, normally when I do these notes in class, I print these diagrams out for you so that you don't have to sketch them in because they can be kind of tricky. But I might encourage you to either like take a screenshot of this page or jot these down in your notes if you can. Just pause the video and jot them down. Because these words, I'm going to define them in just a minute, but these words can be kind of useful to remember throughout the chapter. So the height of a pyramid is still going to be the altitude or the perpendicular segment that goes from the vertex to the base. So rather than connecting two bases like we did in a prism, it's going to connect from the base up to the vertex, right? So here's my height here, or my altitude, it says here, and then my height here goes from the base up to the vertex. The interesting thing about pyramids is we have this thing called a slant height. So it's not the height of the pyramid, it's actually going to be the height of the side. So it's the length of the altitude of one triangular lateral face. In other words, the slant height is like the height of each of the triangles, right, that goes around the side. So here's my slant height on this pyramid. On this one, I don't think my slant height is labeled out, but it would just be the height from the bottom of one of the triangles up to the vertex. Hello, it's me again. For the lateral and surface area of a pyramid, for the formula, the lateral area is essentially going to be each of the triangles added all together, right? So this was the really horrendous net that I showed you guys yesterday, and this doesn't even have a regular square as the bottom, but it's a good visual example. So basically, if I want to find the lateral area, it's like I'm going to take this triangle plus this triangle plus this triangle plus this triangle. And to find the area of one triangle, I would do base times height divided by 2, right? So now instead of just finding one, I'm going to do this base and this base and this base and this base times the height, because the height, the slant height of each of those triangles in a regular base pyramid is going to be the same. So I'm going to do the perimeter actually of the base times the slant height, because the slant height is going to be the height of a single triangle, right? So if you notice, the lateral area is actually almost the same as the formula of a triangle that we know, which is base times height divided by 2, or we could say this is also like 1/2 base times height. But now our base, instead of being the base of just one triangle, is the base of all of the triangles that form kind of the sides or the lateral sides of our pyramid. So then the surface area obviously is just going to be the lateral area plus the base. So we would just say the lateral area is all of the triangles that form the sides of the pyramid, and then we'll just add on that base, that square or hexagon or whatever shape we have. Okay, so a cone is very similar to a pyramid, but just like cylinders and prisms, a cone is a 3D solid that has one circular base, right? So instead of having a polygon for a base, we just have a circle, but all of the words are essentially the same. So the height is again going to be the altitude from the vertex down to the base, and then the slant height again is going to be the diagonal length of the side of the cone. So this is very, very similar, right? The slant height here is essentially the same as the slant height on a pyramid. We're just talking about, it's just kind of one singular curved side altogether. So for the lateral area and surface area of a cone, it's the exact same idea, where this sort of round piece here is essentially like one big triangle. If you unroll it, it's kind of like a rounded triangle. But we can find the area of that one big triangle segment or section up there by finding the base, which is the circumference of the circle, the base of that length for the triangle, and then times the height of the triangle, which is really the slant height here, and then dividing it by 2, right? So the lateral area formula, and you'll want to probably write this down, is going to be the circumference of the circle times the slant height divided by 2, or 2 pi r, the circumference, times L, the slant height, divided by 2. And then our surface area is going to be the lateral area plus the base. By the way, one question that students always ask me in class is, why do we use L for slant height and not H or not maybe S or something? I think S's tend to look like 5s when we're working in math, and H obviously has already been taken. So what we tend to use for slant height is L, and we actually use it more of a curved L, if you can see kind of right here. We use kind of this curved fancy letter L, a script L, for the slant height, because it's much more distinguishable than even just a normal kind of type L like I have up here. So just fun kind of history or reasoning, I guess, behind why we use L for slant height. So example 1, we're going to find the surface area of this pyramid. We know that the surface area is going to be the lateral area plus the base. So our first goal is, of course, we're going to have to find the lateral area. So I know for my lateral area that I need my perimeter and I need my slant height. So if I look at my shape, my diagram that I have over here, I have a really nice slant height given to me of 9 inches already, so I don't need to find that, I already have it. I don't have the total perimeter, but I do have one side length, and I know that this is going to be a regular shape, so I'm just going to multiply it by the number of sides. So L is my slant height, which is 9. My perimeter is going to be 36 inches because it's 6 times 6 sides. And so my lateral area, which is the perimeter times the slant height divided by 2, will be 162 inches squared. Then for the area of the base, going way back to chapter 10, remember that the area of a regular polygon is going to be 1/2 the apothem times the perimeter. And lucky for us, we already know the apothem here. It's going to be 3 squared of 3. And we already know our perimeter because, well, we just found it right here. So fortunately, we just have to plug everything in. So it's just going to be 1/2 3 squared of 3 times 36. And that simplifies down to 54 squared of 3 inches squared. So if I was just going to add them together, notice that 162 doesn't have a square root of 3 on it, and 54 obviously does. So remember, we actually can't add those numbers together. So if it asks you to leave it in simplest radical form, this is going to just be your final answer right there, and you can't really do anything about adding them together. If it asks you to find a decimal form, like round to the nearest hundredth or to the nearest tenth, then you can plug it into your calculator. And I got that 54 square root of 3 is actually approximately 93.53. So I'd add those two together and get 255.53 inches squared. Just wanted to kind of throw that in there. All right, so in example 2, again, we're going to find the surface area of the pyramid, which is going to be the lateral area plus the base. So the lateral area, we're going to have to do the perimeter times the slant height divided by 2, obviously. So the perimeter, remember that this has to be a regular shape for the base, so it looks like it's going to be a square. So the perimeter is going to be pretty quick, right? 30 multiplied by 4 sides, but I don't have the slant height here. That's kind of a problem right now. I'm going to have to find the slant height. If you notice though, I actually have a right triangle going on in here, and I know the length of one of the legs, and because this is a square, this width of 30 meters is going to carry through all the way through the square, right? So the bottom length of this triangle is actually going to be half of 30 or 15 meters down there, right? Wrong color, oops. 15 meters down there. So now we can actually use the Pythagorean theorem to find the slant height. And remember, the slant height is going to be right there, that kind of length from B to A. So I kind of just threw all of my Pythagorean theorem stuff up here at once, but we would do 15 squared plus 36.4 squared, right? A squared plus B squared equals C squared. When I square those, I get 225 plus 1,324.96 equals L squared. And then add them together. And remember, we're going to have to take the square root on both sides to get L by itself. And I get that L, or the slant height, is 39.37 meters. Now that I have that, I can go back and say, okay, I know my slant height. My perimeter is going to be 120 meters. So my total lateral area will be 2,362.2 meters squared. So check, we found the lateral area. Now to find the base, because it's a square, it's just going to be 30 times 30, right? 30 squared will be 900 meters squared. And then when I add them together, I get that my total surface area will be 3,262.2 meters squared. So the whole point of this example is just that sometimes you're going to have to pull out your good old trusty friend, the Pythagorean theorem, to find missing sides or missing pieces that you need to fill out the whole formula. All right, on example 3, our final example, we're going to find the surface area of the cone. So again, we know that it's going to be lateral area plus the base. The lateral area in this case, because it's a cone, we're going to have to use that circumference, right? So it's going to be the circumference times the slant height divided by 2. One thing that a lot of students notice when we're looking at this formula for the surface area of a cone, or the lateral area, is that if I put in 2 pi r for my circumference times the lateral area, and then I divide it by 2, these 2's can actually cancel out before I do anything. So a simpler version of this formula could actually just be pi r times L. The reason why, though, that I always give students this formula is because I want you to be able to think about it as circumference times the slant height divided by 2, right? Because that's kind of how I keep it straight in my head. Perimeter times slant height divided by 2, circumference times slant height divided by 2. But this is kind of the simpler version. You can always go through and just simplify it before you actually plug everything in and do all the math. And it just saves you a little bit of time at the end with simplifying. So I know that my radius is 15. I know that my slant height is 25. So that gives me a lateral area of 375 pi centimeters squared. And I'm going to leave all my answers in terms of pi here. My base, because it's a circle and my radius is 15, will be pi r squared, which gives me 225 pi centimeters squared. So surface area, lateral area, plus the base is just going to be a total of 600 pi centimeters squared. And again, unless it tells you to multiply everything out with pi in it, I would just leave things in terms of pi, right? That's technically a more accurate answer. 600 pi centimeters squared. So again, you don't have to do a summary, but if it helps you to kind of reflect and connect things together, here's a prompt. Describe how to find the surface area of any 3D figure. So just kind of generalize and think about, could you write one sentence to tell someone, how do you find the surface area of a 3D figure? What would you tell them? And then your homework assignment is going to be page 712, which you can find assigned in Teams.